Hi! We are all set to create our logistic regression. In this course, we employ sklearn for the model estimation. Let's import the logistic regression model from sklearn linear model. Next, let reg be an instance of the logistic regression class. Since we'll have a lot of outputs, I want to make sure all the rows will be printed, so I'll set PD options display max rows to none. Great! We estimate our model by fitting the inputs and the targets. To do that, we apply the fit method on the reg object and supply the two data frames, the inputs and the targets. The inputs train data frame contains all the independent dummy variables without the reference categories, and the lone data targets train data frame contains the dependent variable, that is, the good-bad indicator. This command alone will estimate our PD model and will store the results in the reg object. Good job! To get the coefficients of our PD model, we can use the built-in methods. Running reg.intercept underscore gives us the intercept, and reg.coef underscore gives us the coefficients in the order of the dependent variables from the inputs data frame. Great! It's great that we estimated our PD model. Now we just have to take some extra care by extracting and formatting the results in a usual format. We got the coefficients in the order of the dependent variables from the inputs data frame, so we can get the variable names themselves. Let's store them in a dedicated variable called feature name. Feature name will be equal to inputs train, columns, values. Next, I'd like to create a summary table data frame. It will contain the feature names and their corresponding coefficients. Let's start with the feature names. Summary table will be a data frame with a single column called feature name, with values coming from the feature name variable we just created. Now let's add a second column with the coefficients. We already got the coefficients from the reg object using the coef underscore method. The only thing to do in addition here is to transpose them, turning them from a row to a column, as series in a data frame are always in the form of columns. To achieve that, we can take advantage of the numpy transpose method. Great! Now our summary table contains two columns, the variable names and the coefficients of the respective variables next to them. Good. Perhaps now is a good time to add the one coefficient not associated with an independent variable, the intercept. Let's put it in the first row, so it's displayed at the top of the list of the coefficients, as it is well accepted in the most statistical software packages. In Pandas, that is not a straightforward procedure, but bear with me. First, we add one row to the summary table by adding one to the index of all existing rows, which will move them one row down. Then, we fill the first row, that is, the row with index 0, with the values, the word intercept and the intercept itself, using the same syntax as above. Finally, let's sort the summary table by index through the sort underscore index method. All right. Now when we display the summary table, we can explore the variables and their coefficients. Excellent. Let's wrap it up here. Thanks for watching.